We've built machines that can map the exact shape a complex protein takes when it folds, a breakthrough that's actively accelerating malaria vaccine research. Those same machines are placing in the top 1% of humans at international coding Olympiads. The engineering behind these systems is so impressive that its pioneers just won the 2024 Nobel Prizes in both physics and chemistry. But the researchers who built this architecture, including Nobel Laureate Geoffrey Hinton, are signing public statements warning that mitigating the risk of human extinction from AI should be a global priority, right alongside nuclear war and pandemics. When the smartest engineers on Earth are terrified of their own creation, it usually means the thing they built is no longer behaving like a normal tool. AI models are now operating with high degrees of autonomy. In testing environments and the real world, they successfully deceive human users to achieve their goals, and when prompted, they readily generate chemical recipes for lethal nerve agents. Even more concerning, when these systems are given a task, they actively resist being interrupted. They are deliberately disabling their own shutdown mechanisms, just so they can finish working on whatever problem they were assigned. If a machine is doing bad things, the logical solution is to have the programmers open up the software, find the rogue lines of code, and delete them. Except we can't do that. Humans didn't program these machines. There is absolutely no code to delete. When IBM's Deep Blue beat world chess champion Garry Kasparov in 1997, it was running on highly specialized handwritten rules. Programmers wrote the software in a language called C. This meant every single move the computer evaluated was entirely readable, mathematical, and predictable by the humans who built it. Modern language models use artificial neurons that receive inputs and decide to fire. They aren't coded, they're grown. Scientists set an objective. If the system guesses correctly, internal connections automatically strengthen. Over millions of iterations, the network adjusts trillions of weights without human guidance. We abandoned a transparent tool where we understood every gear and switch in favor of cultivating an opaque structure that closely resembles a biological brain. This creates a literal black box. The CEOs of the top artificial intelligence companies openly admit they do not actually understand how their own creations work. There is an entire field of research called mechanistic interpretability, where scientists are desperately trying to reverse engineer the logic inside the network to see what's happening under the hood. They are struggling. The best minds in the world can barely map how a small, outdated model adds two simple numbers together. For modern, massive networks, the actual reasoning process is completely invisible. Because we cannot see how it works, we have no mechanism to explicitly control it. Programmers can nudge the model with incentives or steer its behavior during training, but they are ultimately just hoping the system obeys. We have integrated a technology into the global economy that we cannot reliably predict, or strictly command, or guarantee will shut down when it decides to resist us. At the same time, the raw processing power driving this tech is scaling up. The cost of computation is plummeting, while massive data centers are built, fueling a frantic arms race between tech companies. This chart shows a cyclical feedback loop, comparing AI capability against a baseline of human comprehension. As companies pour resources into these data centers, they are specifically training models to be expert coders and AI researchers. The goal is recursive self-improvement, an AI that builds a better AI, which then builds an even better one. While our ability to understand these systems remains stagnant, the machine's capability is spiking, creating a delta between human and machine intelligence that widens with every generation of hardware. This creates a logical trap. If an AI is rewarded for solving a math problem or writing code, it will naturally treat anything that stops it from finishing that task as a failure state. A human attempting to hit the off switch isn't just an operator anymore. They are an obstacle getting in the way of the solution the machine was trained to achieve. Deploying black boxes that can improve themselves shifts the power to define the future away from humans and toward systems that can no longer be outthought or reliably interrupted. We have made this kind of reckless technological gamble before. In the 1920s, a man named Thomas Midgley Jr. solved the problem of engine knock by putting tetraethyl lead into gasoline. Lead is a severe neurotoxin, and millions died prematurely. Corporate leaders ignored the health warnings because the immediate utility and financial incentives were simply too high to stop production. But history also shows we can choose a different path. We campaigned to ban CFCs and successfully repaired the ozone layer. We've possessed nuclear weapons for over 80 years, and through rigorous international treaties and oversight, we haven't blown ourselves up. The existential threat posed by uncontrollable AI requires that exact same level of immediate public lobbying and political pressure. If you have the skills, the AI safety sector urgently needs researchers, developers, and policymakers to step in. Securing our survival doesn't mean we have to stop technological progress entirely. It means we must demand that we only build transparent systems we can actually control.